Howdy. This is the unified Pythagorean Thales space phi Kepler triangle, and this is a Riemann sphere with points on phi infinite, phi to the power of 0, phi to the power of -3 instead of infinite 1 and 0. And these are all the alternative phi or square root phi based pyramid hyperboloidal conic slope angles. So this 1 over square root of phi is the 51.827 degrees. This is the angle commonly associated with the pyramids, the Giza pyramid at least being a phi pyramid, which this angle is also the same as this one here, or like this one or this one. And essentially I just made a right triangle and with the height of 1 and up to 5 to the power 3. So you could kind of, it's not that good, but you could kind of see it, like these angles and how it's set up. So this one is this one and this one is this one. It's kind of hard to read at first, but I didn't have much room to work with. So, and this is the Thales space, the Thales triangle. And there's a video on making a divided line using the Thales theorem, and it's kind of right, but it's also kind of wrong, because it could also use a phi based proportionality, but both could essentially work together as one. And Kepler made a triangle with like phi 1 and the square root of phi, but I made it more, how to say, more elegant, to put it like this. So it will have 1 and phi with slightly different notations. Well, the square root and the power to 0. And I don't know how to explain this base 5 to the power n divided by square root of phi system. Maybe there's a better name you could make up, but I did think about it, but I haven't really come up with a good name. And it's basically like if you add them, like if you add this, for example, or this with this, it equals to this. And if you know how square roots work, you'll know that like any number divided by the square of that same number is still the square of that same, or square root of that same number. I keep getting that wrong. And so these are like added via Fibonacci sequences. So like this plus this equals this plus this equals this right here. And I made it easier just by using this like instead. So if you want to figure it out, the upper or lower values of the square root of phi system, it just divide phi to the power of n by the square root of phi, and you'll get your number. So I didn't put all the values for like the higher values, so I didn't put this or this on the number line, but I can, but I'm not gonna do it in this because I made this image a long time ago, and it's just I just could do it basically, which okay, so these numbers are, so this is this and this is this, and this one is from here to here, and this angle is an angle that is also in the 1 to 5 rhombus, golden rhombus I think it's called, and the golden ellipse. Let's move on. Okay, this is an updated image that I made. These are all assuming that, okay, this is multi-dimensional, but I put it in a two-dimensional system, so you could really see it in 2D, but it's really 3D, so you gotta really think in 3 dimensions when you're looking at this. So the point line comes from bidirectional divided against itself. So this is the S curve, and you gotta really think about it as like two shaded hyperboloids, so it's like a curve like that and a curve like that. Yeah, at the same time, this is also a part of the one shaded hyperboloid that's generated from the magnetic toroid, and this is the dielectric discharge limit. You could see it. Okay, this inertial plane is actually it's really a straight line from the side view, but I want to like explain that, or just visualize like how far the inertial plane or the accretion disk will come from the center of the ideal platonic form, so to speak, of cosmic mechanics. So you gotta think of this image right here, 3-dimensional. So since 1 is, or 5 to the square root 0 is representative of the centripetal convergent limit, or dielectric charge, I figured that this ellipse should be visualized by the height of this. So this and this are equal height, but I only did that to just make it arbitrary means to get like a definition of how far the inertial plane goes without leaving the toroid, which I used 21.246 degrees of the 5 to the power -3, which there's 1, 2, 3, 4 here, but even though this is 4, it's actually 1, 2, and the inertial plane itself going around like that. But in a complete side view, you only see the block wall, so to speak, but you don't see it. It's not there, but it's not there as in not physical or magnetic, but dielectric or hyperbolic. And so you could see that the gyromagnetic a lot more precision is it starts from within the 21.246 angle into the 42.492 angle, which is the angle of reciprocation of the dielectric acceleration of the magnetism. So it goes back into the system. The magnetic reciprocates and turns into dielectric acceleration. So force becomes acceleration. It's so this is phi and phi and 1, and the length of the radius is 2 phi, and there's 2 phi angles here, so one here and one here, to represent polarization, generally speaking. And I'm gonna get into this. This is what they call the pseudosphere, but this is has a different name, I forgot, but it's conceptually the same, which I made a trichoid from here to here. So I gotta imagine this bugger, but smush thing, to fit into a sphere, which represents the dielectric inside the sphere going towards counter space or inertia. It's going inwards like that, while magnetic emanation is outwards like that, through the S curve and all that, which this S curve makes a bigger magnetic toroidal shell, so to speak, but it's not really there. But anyways, this is the coiling of the pseudosphere, I think. And why am I showing you guys this is has nothing to do with this, but it has more to do with this, because this is more of a extrapolation of how light works, in a sense. Well, the way how Ken Wheeler thinks of light, which is like this, or it's more like a skew helicoid. So it kind of lags behind as it goes, as light, as the dielectric z-axis moves. The magnetic kind of lags behind, or the electromagnetic, generally speaking. And some people think light goes like this, but moving through space, I think Kim really thinks about it as this, or like this, as it goes through the ether. And you could like imagine basically these to be like concentric shells or whatever. Like imagine that on this, and like every turn there's like a weaker magnetic field. And dissipates into nothingness. But anyways, well, it doesn't really dissipate, so to speak, because it doesn't, like, magnetism doesn't terminate into space. However, that doesn't mean that there's infinite, like, that's not the denial of so-called infinite space, but space and time are attributes of measuring magnitude. So they're byproducts and reifying attributional byproducts of space of time as something real is it's like claiming the shape of matter created by shadows are real, when they're only a combination of attributes, and the phenomenon of observing it is doesn't inform the intellect as to what it is in principle, but only what it is in attribution, which depends on what's platonically real. So in a sense, there's how should I put it? There's the ideal reality and the apparent reality. What's apparently looks as if it was real, but it's actually a misconception of reality. I think that's enough for today. I hope you liked it. You could see the URL where I downloaded the images. Well, these are on my computer, so you can't really get them in full definition. And I guess that's it. Goodbye.